Good morning, students. Today we will discuss about next topic in atomic structure. This is 11th class topic. So that is Bohr's atomic model. Bohr's atomic model. Bohr's atomic model. So Bohr's atomic model. What are the postulates of Bohr's atomic model? Today we will discuss about Bohr's atomic model, and it is very important. Postulates. Important postulates. So what are the important postulates of Bohr's atomic model? So one by one we will discuss. First postulate is electrons are revolves around the nucleus in circular paths. These paths are called orbits, shells, or energy levels. This is first postulate. Okay. So this is nucleus of an atom. So these are called shells, like this, shells. Electrons are revolves around the nucleus in circular paths, certain fixed circular path. Okay, circular path. These paths are called as orbits, or shells, or energy levels. Three names are given. Energy levels. So these are denoted by K, L, M, N, O, or 1, 2, 3, 4, 5 from the nucleus, from this side, from nucleus side. These are denoted by K, L, M, N, O, or 1, 2, 3, 4, 5, so on from the nucleus. So next postulate is why these are called as energy levels. Why these are called as energy levels? Because a certain fixed amount of energy is associated with the revolving electron. So here the electron is revolving like this. A certain fixed amount of energy is associated with the revolving electron. Therefore, these orbits are called energy levels. These orbits are called energy levels. This is second postulate. So why these are called as energy levels? Because a certain fixed amount, when it is revolving, a certain fixed amount of energy is associated with the revolving electron. So that's why these orbits are called energy levels. Next, third postulate. So third postulate says these orbits are called stationary orbits. Why they are called as stationary orbits or stationary energy levels? So electron is, so when the electron is revolving in this orbit, it does not emit or absorb energy. So the energy of electron remain constant. When the electron is revolving in this orbit, it does not emit or absorb energy. The energy of an electron remains constant. That's why these orbits are called stationary orbits. So what is meant by stationary means? Energy of electron remain constant. This is third point. That's why these orbits are called stationary orbits or stationary shells or stationary energy levels. Fourth postulate says the moving electron revolving electron angular momentum. So what is angular momentum? Angular momentum. Angular momentum means the product of mass, velocity, radius is equal to nh by 2 pi. So angular momentum of electron, revolving electron is equal to mass, the product of mass, velocity, radius is called angular momentum, nh by 2 pi. Here m equal to mass of electron, m equal to mass of electron, v equal to velocity of electron, v equal to velocity of electron, r equal to radius of orbit, r equal to radius of orbit, n equal to number of orbit, in which orbit electron is there, n equal to number of orbit, h equal to Planck's constant, h equal to Planck's constant. It is Planck's constant. So h value is 6.626 into 10 power 6 I will write here 6.626 into 10 power minus 34 joule second. This is the value. Or 6.625 into 10 power minus 27 erg second. So this is the angular momentum of electron. So pi is also constant. After that, so this is the four postulates. Fifth postulate. So fifth postulate is jumpings of electron. So fifth point has remember as jumpings of electron. So electron can jump from one orbit to another orbit. Here this is lower energy level. It is higher energy orbit. It is lower energy orbit. It is higher energy orbit. Here two cases are observed. If the electron is jumped from lower to higher orbit, in first case lower orbit to higher orbit. It is lower, it is higher. It is lower orbit, it is higher orbit. What happened? It absorbs energy. Electron can absorb energy. In second case, electron can jump from higher orbit to, it is higher to lower. It emits energy. So lower to higher means it emits energy in the form of radiation. Radiation is nothing but light in the form of radiation. So higher to lower it emits, lower to higher it absorbs. So what is the difference between delta E equal to E2 minus E1 that equal to H nu? So delta E is the difference between two energy levels, E2 is the energy of higher orbit, E1 is the energy of lower orbit, and h is the Planck's constant, mu is the frequency of radiation. So here delta E, difference between, for example, electron can jump from 4th orbit to 3rd orbit. 4th orbit to 3rd orbit, delta E equal to E4 minus E3. I will write like this. So E4 minus E3, that equal to h nu. That equal to h nu. Nu is the frequency of radiation. Nu is called as frequency of radiation. H is called as Planck's constant. Planck's constant. So E2 is the energy of higher orbit. E1 is the energy of lower orbit. This is about jumpings of electron. Jumpings of electron. After that, last postulate is so 6 point is this is nucleus. So electron is revolving like this. These two forces are acts on the electron. One is towards the nucleus. That is called centripetal force. That is called centripetal force. Away from the nucleus, that is called centrifugal force. That is called centrifugal force. So centripetal force, this is centripetal force, this is centrifugal force. So this is revolving like this, electron is revolving like this. The electron, it is balanced, electron is balanced by two forces. One is centripetal force, which is towards the nucleus. Centrifugal force, which is away from the nucleus, means by the revolving gain one force, that is called centrifugal force. Therefore, centripetal force of electron is balanced by centrifugal force. That's why electron is revolving around the nucleus in circular path. Otherwise, if these two forces are not balanced, electron can fall into the nucleus, atom will collapse. So this is very important point. This is last point, that is centripetal force of electron is balanced by centrifugal force. So that's why electron can revolve in the orbit. So first point is shells. Electrons are revolves around the nucleus in circular paths. These paths are called orbits or shells. These are denoted by K, L, M, N, O, so on, or 1, 2, 3, 4, 5 from the nucleus. After that, energy levels, certain fixed amount of energy is associated with the electron. That's why that is called, they are called as energy levels. Stationary orbits, the energy of electron remain constant when it is revolved in the orbits. Therefore, they are called as stationary orbit. Angular momentum of electron MB are equal to NH by 2 pi. Next point, electron can jump from one orbit to another orbit. It jumps from lower to higher, absorb energy. It jumps from higher to lower, emits energy. Electron centripetal force is balanced by centrifugal force. These are the 6 postulates of Bohr's atomic model.